Welcome to a new test and teardown video. This time it's another one of those battery backed up power supplies from DMI. This one is called a DCU buffer power supply. And we got on battery and we got on power line. The reason why I want to show you this is actually there are a few funny and cool design things in this one. So it's this one got a battery inside. I already opened this one to try and make the video a little bit shorter. So here we go. I think this is probably from 1980 or something. So this is most likely nickel cadmium cells. And of course this is I would assume this is a 12 volt power supply. Yes. Plus 12 and minus 12 volt DC. We also got those supply voltages on DIN connectors, and they also use this for a lot of things. And the good thing about exactly this type of DIN connector is, as you can see, it got this plug in and turn locking mechanism, so you can't really connect anything wrong and it can't really fall out all by itself. This is far more safe and stable compared to this, right? Because people can mount this wrong and it can fall out if you're pulling the wires. And what they also did, they removed a few of the pins here. So if you see here, those two pins right there, they're removed to create a little bit more spacing so we don't see any short circuits. So that's quite alright. It's the same connection for everything here, if it's the banana plugs or if it's that. I only measure a half a volt over all the batteries. So we got what, 14 1.2 volts in series, so that will be like 17 volts. So let's try something funny. Let's try and connect this to a power supply like this. And let's see if we can get the voltage up and see if there's any way this can deliver a little bit of current. Look how fast voltage just goes up. You could even let's just try and be real mean. Try and wake these up. Ooh, look at that. And then what happens? I think I'm just gonna crank this down again and just leave it like this. So now it's quite safe to leave. Is it safe? I don't know. So while this is still charging a little bit, let's play along with the power supply. And the thing I really wanted to show you was actually this part here in the middle. But first let's see, that will be the two secondary windings from the transformer. And we got into a rectifier, inductor, and then capacitor. And then that goes into a positive 12 volts. That's our 12 volts, right? But this input here is also via diodes and resistors and kind of stuff. This is the battery and the battery enable kind of switch. So you can select to run on the battery or not, right? So to generate a high voltage to charge the batteries, look what they have done here. So that is the AC side that goes through a voltage doubler and then charge resistor. I mean, it's quite funny construction here, right? And then here in the middle there is something really, really funny. Look what that is. So here is a 4047. So this is an oscillator and a flip-flop with two outputs that goes positive, negative, like the flip-flop. And it's controlling those two transistors. So that is actually a half-bridge push-pull via a little transformer, rectifier, and capacitors. So that is our negative 12 volts. And I don't see if there's any feedback or anything like that here. So it's just making a negative unregulated supply. So where's this yellow wire going? Is that going all the way out here, or is there some secret stuff underneath? Like a negative regulator, I don't know. Also look at this positive regulator here. It looks like you could also mount a big TO3 type of regulator. But how about we power it up and let's see if this works. So let's try and test this 12 volt power supply in mains mode. And there is no output. Well, oops, that can't be good. Poof, puff, poo. Did you see that? Smoke signal. Oh no! Yeah, that was lots of funny. Now it's ice cold in here because we had to open all the doors and stuff, and it still smells bad. But anyway, I just saw the previous clip, and it actually turned out I had 12 volts output here. So let's try and turn it on again and then measure. Look at that. See, I got 12 volt out. Of course, I don't have any voltage here. What? I got a lot of voltage here. So how the heck is this? How is that possible? So this thing just melted and then everything is fine. 38. So I got 38 volts on the input side of a 12 volt regulator. Oh my God, that is way too much. And it is probably coming. So here's 39. Why are we having 39? So it's coming this way. Aha, this is how it is. It's backfiring this way because we haven't got that much here. I think we'll have to try and disconnect this inductor. Is probably melted. But how is that possible? What made this melt? Because this short is not here anymore. That is some weird. This is actually a little bit funny. Let me turn this on again. So there is still a nice short in this inductor, so the problem is just gone. Everything is working again. Okay, so this is the input to the converter that is running on positive 12. So the output of this converter, let me see if I'm able to grab that one, minus 22. Okay, so what is the output here? Minus 22. So that is what it is. So there is no regulation or nothing. So that is probably unloaded. Yeah, I don't see any resistors or anything here at all. So if I load it, see, even just loading it with my voltmeter, and then the voltage goes down. So I'll try and put a little bit of a load resistor on that one and see. I turned it off, so why is it okay? Now it goes down. Why is it still up that? So those capacitors, they just last for a long time. I don't know. There is no other parts down there. I'll see what I did here. I disconnected the voltage doubler on the input side, the AC side of this voltage doubler, and now the voltage here is only 22 volts, so now that is all right. So I mean, this charger here, you can't disable it or anything like that. So this is the battery voltage, and you can turn that on and off here on the front with this this switch here. So that means if this is turned off, the very high charge voltage of 38 volts just goes all the way through here, this diode, and will actually kill this regulator. It just survived, but by pure luck. And initially, I think this capacitor was shorted, but this short kind of just went away with this high current pulse that went through this inductor, and this is where we saw all this smoke coming from. And now this short in this capacitor is gone, and you see the voltage here is perfectly fine, and now everything here runs as good as normal. So let's play a little bit with this converter. I've now loaded it with is that a 4K7, so that's not that much. And look, now the output voltage is very close to minus 12 volts. How about we take a scope and let's look at the switching frequencies. So here is the switch mode power supply. I'm looking at the two collectors of the two NPN transistors, and as you see here, we are running at 11 kilohertz, and there isn't really any dead time at all. It's just flip flop flip flop, and that's just how it is. And of course there's a little bit of overlap and all that kind of stuff. Let's just zoom in here. Okay, so this one actually do turn off before the other one turns on. Okay, so that is not so bad. Let's look at the other edge. Yeah, okay, well, not a lot, but I prefer to see dead time, and actually quite a lot, to be honest. That is better for a switch mode like this. This way you don't get these funny ringing up here. Let me see if I can show you what I'm talking about. This kind of stuff here. But it's actually not this bad because they're using really slow NPN transistors. But yeah, you could definitely make your own little switch mode converter like that. So this is exactly what they did. Oops. So yes, I was right. Nickel cadmium. 1.2 amps hour. I'm actually still charging. Ooh, be careful not to short this. Ooh, oy, oy. But I wanted to see if there's any kind of current left. So here we go. This is a little 12 volt. Oy, oy, oy. Look at that. Oh. But there was actually a little bit left in a 40-year-old battery pack. How funny was that? Alright, thank you very much for watching, and see you again tomorrow. Bye bye.